Hello students, today we are going to study about the calculations and errors. Basically we are going to talk about the topic where errors are used and we need to calculate different types of errors. So I'll start with an example and that will give you an idea about different types of error. Let us say that we have a simple pendulum and some students are taking the observation of the time period of the simple pendulum, alright, the time period of oscillations. So the readings are like this. Let's take 5 readings, 2.8 seconds, 2.9 second, 3 second, 3.1 seconds and 3.2 seconds. These are the 5 readings. We will first of all, before moving on to any type of error, we are going to first talk about, let's calculate mean value. So we already know how to find the mean value. The mean value is taken, mean is basically the average value. So average is taken by adding all the values divided by number of calculations or number of observations, right? So this is, we have to add them all up. So 8 plus 2 is 10, 9 plus 1 is 10. So we have got 20. So 0.02 is in carry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 2 carry 15. Over number of observations are 5. So 15 over 5 which gives us the value of 3. So right now the mean value of the given observations is 3. Now let's talk about various types of errors. First one is called absolute errors. Now absolute error, I am writing errors because absolute error is present in each value, because we don't know. See, if you are finding out the value of time period of an oscillation and if you are getting 5 different set of values, that definitely mean that 4 of them are wrong. Even all 5 may be wrong and the closest one might be this or this quantity. So you might never get the actual value, okay. That means either all of them are wrong or one value is very close to the original value. So absolute error is figured out by subtracting the mean value from each individual observation and taking its modulus. So absolute errors is in each value. It is denoted by delta T1. This is the absolute error in first quantity, which is the first quantity minus the mean value. Similarly, absolute error in second would be second quantity minus mean value, but we are going to take the modulus every time because we are not going to take error in a negative sign, alright. So now I am not going to write the formula, I will directly write the answer, which is delta T1 would be 2.8 minus 3 modulus, which is 0.2. Then this one comes out to be 2.9 minus 3 modulus, which is 0.1. That delta T3, this is 3 minus 3 comes out to be 0. Delta T4 is 3.1 minus 3, which is 0.1, and lastly delta T5, which is 3.2 minus 3, which is 0.2. So we have got all individual absolute errors. Now we are going to find, this one was the first, which is absolute errors. Second one is called mean absolute error. Now mean absolute error, as this name suggests, would be the mean value of all the individual absolute errors, okay. So how do we find out the mean value? Just add all the different values and divide it by number of observations. So we have 0.2 plus 0.1 plus 0 plus 0.1 plus 0.2. This whole divided by number of observations are 5, right? So we got 2, 3, 4, 5, 6, 0.6 over 5, which is equal to 0.12. So this is the mean absolute error. So if you need to write the formula of mean absolute error, it would be what? It is absolute errors, that is delta T1 plus delta T2 plus delta T3 divided by n. N is the number of observations. Then the next type of error is called relative error. Now, relative error has a very simple formula, which is mean absolute, I should denote it by delta t bar, because mean value is, if these are the 5 observations, then mean value is often denoted by t bar, right? So instead of t bar I am using this symbol t mean. So here also mean absolute error divided by mean value of the whole system. So mean absolute error was this, which is delta t bar upon the mean value. So what is delta t bar? We have 0.12 over the mean value was 3. So we have got 0.04. This is the mean absolute error, right? No, it is not mean absolute error, this is relative error. Mean absolute error was adding all the individual absolute errors divided by the number of observations, right? But in relative error we divide the mean absolute error and the mean value, okay? The last part would be percentage error. Percentage error. Now percentage error has the simplest formula, which is relative error times 100. Whatever your answer would be, that is the percentage error in the overall calculation. So again it is mean absolute error divided by mean value times 100. So in this much percentage, so in this example which we have taken, the relative error was 0.04. So 0.04 times 100 gives us 4. So 4% is the answer, which is 4% is the percentage error in overall calculation.